So now we come back to, well, partial circuit that I did in the last video. So we have a 555 timer here in Astable mode. It's setting the output high and low, you know, about 50% of the time high and 50% of the time low, approximately. And so yeah, there you can see the waveform. I set the power supply to 5 volts. It made things a little easier with 6 volts. But in any case, the capacitor is discharging down to 1/3 supply voltage, charging up to 2/3 supply voltage. Now, I have, you know, we're measuring the capacitor right there with the oscilloscope. Got the alligator clips. I just clipped them to jumpers that I could plug into the breadboard. So that's the output there. This is not related to the output at all. I could remove these. It's just kind of responding. It's actually just responding to the voltage of the capacitor there. So we have a 100,000 ohm resistor there because we don't really need current. Just a tiny current allows a lot more current to flow through the transistor. Ultimately though, the voltage we're given to the base of the transistor is going across the LED. And this is a 100 ohm resistor so that the LED will get brighter. And it transfers that voltage, but you lose about 0.6 volts. Okay, so yeah, there's that jumper going to the capacitor. Now, what I really want is maybe, I don't know for sure, but maybe a white light. So this white light was not very bright when I had the 220 ohm resistor protecting the LED. But yeah, there we go. And so that one, I'm not sure how much I like that, but I'm going to show you some adjustments that I can make. So we are getting up to 2/3 of the supply voltage. Where that 2/3 supply voltage is connected to pin 5 as well. So we can actually raise that. There's 3 resistors that make up a voltage divider, and so down here, that's where the one resistor covers. And then we got the other resistor covering those 2 points, and then the third resistor going to the positive supply. That's within the integrated circuit. Those aren't on the boards. If I plug this trim pot in, and I'm going to turn the trim pot so it gives maximum resistance, 10,000 ohms of resistance right there. This is you know, about the 2/3 spot, probably a little bit higher. But you can see if I turn the trim pot, I'll just go halfway right there. Now we're even higher right there. I can turn the trim pot up. So I want to go, I was working with 6 volts in the last video, so things don't look exactly the same. But yeah, there we go. We can go up that high, and now, yeah, it will still keep working. So we'll come back. It's taking longer to charge, so this LED is going to be lit longer right there. And so I want it so that it starts fading sooner. So what I'm going to do, actually I'm going to replace this resistor. That's what I need to do. So that way, these are both 10K resistors, 100 microfarad capacitor right there. So I'm going to pluck that, and yeah, I think this is the 1K resistor. Yep, 1000 ohms there. And so it should start charging about 10 times faster than it was, which is what I want. So yeah, there you can see right there. We have, it looks like, you know, somewhat close to charging and discharging about the same time. We could modify this a little bit more. I can adjust the trim pot until I see something that I like. So I want to see kind of more of a sawtooth right there. And so yeah, we may be charging a little too quicker. I might want to use a higher value resistor. But in any case, there you can see I basically got the effect that I want, where it fades up and then fades down right there. White doesn't look as cool as red does though, I don't believe, when you have a fade like that. I have other uses for that light than for looking cool. I think usually red looks kind of the coolest when it's fading up and down. I don't know how well that's showing up on camera there. So if I zoom in a little more, it'll look a little cool. So yeah, we have you know, the just on off of the red there, and then the blue, you know, alternating. you can see that one is fading. It's got kind of like a pulse. And again, we could slow it down with a little more resistance and some other fine tuning right there. So, yeah, that's about it. I want the effect of controlling a white LED. You know, I might not need to be a white one, but I think white will work the best. We can also use the blue. But yeah, the red I think looks the coolest. We'll see how the blue looks. Again, this is just kind of playing around right here. I'm trying to get a fade with all common components right here. It's a 555 timer. You can just make tons of circuits with 555 timer. Generally, you use the output though. I just have this to illustrate that the output's going high and low. The oscilloscope is measuring the capacitor voltage. And ultimately, the capacitor voltage is getting transferred over here. But since we're using a transistor, we're just kind of giving a weak signal of that voltage. And then the transistor is providing the rest of the power by drawing it from the power supply right there. So you want to take as little as you can from the capacitor. And then when you transfer the voltage. If I just made a direct connection, the capacitor would like discharge there and it won't charge anymore at a certain point. So in any case, again, just kind of an update of what I'm working on. And I think you know, it's better to make, you know, a bunch of small videos as I make progress instead of just one long video that probably not a ton of people will see. But you know, they'll see, you know, bits of my working on my project and hopefully still enjoy. So thanks for watching. Make sure you check out one of the other videos I posted on the screen and check out the links down below. They all help out a lot. I'll see you in the next video.